In this video, we want to find the area between two curves. If you take a look at the diagram, we've got two curves, y equals f of x in blue and y equals g of x in red. We want to find the area between the two curves, the area shaded green, between the limits a and b. This can be found using the formula the area is equal to the integral between a and b of the modulus function f of x minus g of x dx. Or, in more simple languages, the area is the integral between a and b of the modulus of the upper function minus the lower function dx, while x is between a and b. I'm now going to show you why the formula works. First thing I'm going to do is split my diagram up into four sections. So this section is A, this green section above the line is B, the green section below the line is C, and this section is D. So if I now integrate between A and B, f of x dx, that is equal to the sections A plus B plus D. If I then integrate between A and B, g of x dx, that is equal to the sections A minus C, because it is below the line, plus D. If I then subtract g of x from f of x, so I'll get f of x minus g of x, that would be equal to a plus b plus d minus a minus c plus d. And as you can see, the a's cancel, the d's cancel, so I am left with b minus c, which is equal to b plus c, which is the area of the green section. Now let's go through some questions. So question 1. The shaded region R in the following diagram is bounded by the two curves y equals fx squared minus 12x plus 8 and y equals minus 3x plus 29. Find the area of the enclosed area R. The first thing we need to do is find the two points A and B. In order to do that, they're intersection points, so we put the two graphs equal to each other. So therefore 5x squared minus 12x plus 8 is equal to minus 3x squared plus 10x plus 29. So if we rearrange that, we get 3x squared minus 22x minus 26 is equal to 0. If we solve that by factorizing, we get 2x minus 7, 4x plus 3 is equal to 0. Therefore, 2x minus 7 is equal to 0, or 4x plus 3 is equal to 0. Therefore, x is equal to minus 3 over 4, or x is equal to 7 over 2. We can now set up our integral. So it's the integral between us minus 3/4 and 7 over 2, the modulus function f of x minus g of x dx. If we look at our two functions, the one that is always on top is minus 3x squared plus 10x minus 29, and the one that's always below is 5x squared minus 12x plus 8. If we put those into our integral, we get the integral between minus 3/4 and 7 over 2, the modulus function of minus 3x squared plus 10x plus 29 minus 5x squared minus 12x plus 8 dx, which gives us the integral between minus 3/4 and 7 over 2 of the modulus function minus x squared plus 22x plus 21 dx. So we want to evaluate the modulus between minus 8x cubed over 3 plus 11x squared plus 21x between minus 3/4 and 7 over 2. So we want the modulus value of minus 8.4375 minus 93.9167, which gives us a final area of 102.354. Question 2. The diagram below shows a sketch of part of the curves with equations y equals x squared plus 8x minus 1 and y equals 4x squared minus 5x plus 3. For later n, my curves y equals 4x minus squared minus 5x plus 3 will be g of x, and the curve x squared plus 8x minus 1 will be f of x. The shaded region in the diagram is the area bounded by the two curves. A. Show that the area of the shaded region is given by the integral between 1/3 and 4 for 13x minus 3x squared minus 4 dx, and part B, hence find the area of the shaded region. The first thing you need to do is to find the 2 points I'm marking in blue, which are the intersection points. At the intersection points, I know that 4x squared minus 5x plus 3 is equal to x squared plus 8x minus 1. So therefore, I get 3x squared minus 13x plus 4 is equal to 0. I can factorize to get 3x minus 1 brackets x minus 4 is equal to 0. Therefore, I get x is equal to 1/3 or x is equal to 4. I now have to set up the integral, so I get the integral between 1/3 and 4 of x squared plus 8x minus 1 subtract 4x squared minus 5x plus 3 dx, which gives me the integral between 1/3 and 4 of the function 13x minus 3x squared minus 4 dx. I'm now going to use the TI Nspire to solve this definite integral. I've opened my TI Nspire to a calculator page. Now I find my integral button and I want it between 1 third, and 4. I want it to be the modulus, so I find my modulus. Now I put in my function, which is 13x minus 3x squared minus 4 dx. Press enter, and that gives me an area of 24.6481, which is 24.6 to 3 significant figures, which equals 24.6. So that is my area between the two curves. Question 3. Determine the area of the region enclosed by the graphs y equals sine x, y equals cos x equals pi over 2, and the y-axis. If I draw a diagram of the given information, I will get the following picture. I need to determine the intersection point, and that is found when sine x is equal to cos x. If I use the unit circle, I can clearly see that the only place in the interval 0 to pi over 2 this occurs is when sine is root 2 over 2 and cos is root 2 over 2, and this occurs at the point pi over 4. Therefore, x equals pi over 4. From the diagram, I can also see that I need to set up two integrals, one for area A and one for area B. In area A, cos x is always above sine x, and in area B, sine x is always above cos x. Therefore, the area is given by the integral between 0 and pi over 4 of cos x minus sine x dx plus the integral between pi over 4 and pi over 2 of sine x minus cos x dx. I'm going to solve this using GDC. I've opened my TI Nspire at a calculator page, so now I'm going to type in my integral. So find my integral button, and my first one goes from 0 to pi over 4, and the equation is cos x minus sine x dx plus the integral between pi divided by 4 and pi divided by 2 of the function sine x minus cos x dx. Now hit enter, and I've got the area of 0.828427, which is equal to 0.828 to 3 significant figures. Don't forget to answer the final question. So the area is equal to 0.828 units squared to 3 significant figures.